Hi class, today's preparation in this lecture is about non-annual compounding of interest. So, intended learning outcomes, what I want you to get out of today, by the end of this lecture and the corresponding assignment, you should be able to distinguish between nominal and effective interest rates and calculate one from the other. That's it. So let's talk a little bit about compounding interest. You've learned how to compound interest when it occurs once a year, right? You can tell me if I have a 1% interest rate per year and I start with $100 in the bank, you can tell me how much money is going to be in that bank account 1 year later, 10 years later, 100 years later. What happens if the period over which that interest is compounded is different? So sometimes the period corresponding with an interest rate is shorter than 1 year. We might say that an account earns 1% interest monthly, and it begins with $100 at the beginning of the year. How much does the account have after 1 month? How much does the account have after 1 year? What's the effective interest rate per year? And how much does the account have after 10 years? So let's take a look at these questions individually. How much does the account have after 1 month? Well, does it really matter whether we have an interest rate that's 1% per year and we wait 1 year, or if it earns 1% interest per month and we wait 1 month? It's the same thing. Ultimately, the formula is the same. And what we have is the formula for the future amount is always the principal, the amount that you started with, times 1 plus the interest rate, the effective interest rate I, to the number of periods, n. This can be months, years, it doesn't matter. You just need to make sure that your effective interest rate corresponds with whatever unit of time that you're using here. So if, in my case, I have an I is equal to 1% monthly, 0.01, and I have, in this case, n, it's per month, n is equal to 1 month, for the first bullet point, n is equal to 1 month, because this is in per month, and this is in months, then I can simply plug it into my formula here. So the future amount after 1 month is equal to the 100 that I started with times 1 plus 0.01 to the 1. So after 1 month, it's going to be 100 times 1.01 is $101. Easy. All right, so we got that one out of the way. How much does the account have after a year? All right, the future amount, same formula, is equal to P, the principal, times 1 plus I to the n. Nothing's changed except for the value of n here. I is the same. So I is still equal to 0.01, but now n is equal to 12 months, 1 year. Okay, so plugging that in, we have F is equal to the initial amount is $100, and we're going to multiply that by 1 plus 0.01, the effective interest rate per month, to the 12 months. Let's see if we can get that to be evaluated for me. $112.68, not just 112, but 112.68. Now, what's the effective interest rate per year? Well, we can tell pretty easily by this. The effective interest rate per year, well, we can just rearrange. Let's rearrange the equation, and we'll see how we can figure it out from this number here. So let me write that number down just so we don't forget. $112.68. Okay. So what's the effective interest rate per year? Well, the effective interest rate is kind of like, well, F over P is the amount that the factor by which it grows, right? The factor by which your money has grown, and you subtract 1 from that to get the interest rate. So the effective interest rate is per year is this thing here. So why do I think I can get the number from this? Well, F over P minus 1 is 112.68 minus 1. Well, over 100 minus 1. So it is 12.68% is the effective interest rate, a little bit more than 12. And then how much does the account have after 12 years? Well, there's two ways that I could do that. I could say, well, I'm just going to use the same formula here, and I'll plug in an interest rate of 1%, and n is going to be in months. Or I could use I for the year that I've just calculated here, 12.68%, to the number of years. So let's do it both ways, and we'll see that we get the same answer. So here's way number one that we could figure this out. Okay, check that off. The future amount is equal to the principal of 100 times 1 plus I to the n. We're going to do it in months first. So is equal to 100 times 1 plus 0.01. How many months? We've got 120 months in 10 years. So I'm just going to go ahead and calculate that myself. That is $330.04. All right, and method number 2, we'll do it in years. F is equal to P times 1 plus I to the n. I'm writing this so many times because it's a really important equation. Let's do it in years this time. So here, still same principle, but I is, we're talking about a yearly basis, 12.68%, so 0.1268 to the 12. Excuse me, this is 10 years. And that comes out to be, after I've done some rounding, because I rounded at 12.68%, didn't enter any more decimals into my calculator, 329 and 97 cents. So very close. We're off by a few cents because we rounded here. This formula is always going to be correct for you. It's always going to give you the right answer if you make sure that I, your effective interest rate, and n, the number of periods. So I has to be the effective interest rate per period, and n is the number of periods regardless of what the period is. All right. Sometimes interest is compounded more frequently than once per year. And in that case, you use a formula to calculate the effective interest rate. And this is something that you can just remember. This is just what the idea of compounding more than once per year means, is you get your effective interest rate per period by taking the nominal interest rate per period, the interest rate that you say that you're compounding more than once per year, and you divide that by the number of times that the interest rate is compounded per period, and you take this quantity and you raise that to the number of times the interest is compounded per period. That is a strange way of specifying the interest rate and saying that it's compounded more frequently than once per year. I don't know what the history of it is. I don't know why they don't just say that the effective interest rate is this, and this is how often, they do it every month or they do it every day or whatever. But sometimes they give a nominal interest rate. They say it's compounded more than once per period of time. And so you just need to say, plug it into this formula and find out what the effective interest rate is per period before you can do any calculations. All right, so let's do the same problem, but we're going to use this compounding more frequently than once per year. So here's an example. The account is said to have a nominal interest rate now of 12% per year. Nominal interest rate is sometimes called APR, annual percent return, or annual percentage rate. So it has a nominal interest rate of 12% per year, or APR, but interest is compounded monthly now. It begins with $100 at the beginning of the year, and the questions are, how much does the account have after 1 month? How much does the account have after 1 year? Same questions. What's the effective interest rate per year? And how much does the account have after 10 years? So let's go ahead and give that a shot. Let's remind ourselves what the equation is. So the approach is going to be, we're going to find the effective interest rate based on the nominal interest rate of 12% and the number of times per year that it is compounded. And we're going to raise it to that, etc. So let's go ahead and go into here. give ourselves a little bit of space. So the problem that we did above was when we had 1% interest per month, and then how much do we have, etc. Now we have 12% as the nominal rate per year. And so we are going to start by finding what the effective interest rate. So this is, so 12% per year compounded month. Whereas before we just said it was 1% per month, and it's compounded monthly. But now we've got 12% per year compounded monthly. So first we find the effective interest rate per year. We'll say the formula is 1 plus the nominal interest rate, 12%, divided by m, the number of periods per year that it's compounded, to the m, and then it's all minus 1. Well, in this new case here, we've got r, our nominal interest rate was 12%, and m, we're compounding 12 times per year, once per month, and so we get 1 plus 0.12, 12%, divided by 12 to the 12 minus 1, and that's equal to 1.12, excuse me, not 1.12, 1.01. This becomes 0.01 to the 12 minus 1, and that turns out to be 12.68%. Okay, let's continue on with this calculation. Now that we've found the effective interest rate per year, let's figure out how much the account have after 1 month. So we use our same formula as above. It's valid now because we have an effective interest rate per year. We're going to have that initial $100, and it's getting multiplied by 1 plus 0.1268 is the effective interest rate per year to the n. How many years do we have? We only have a 1/12 of a year because it's once per. We're figuring out the first problem, how much does the account have after 1 month? If you work that out, it is going to be, turns out, 101, right on the nose after you do. So after 1 month, it turns out to be the same. Now, why? 12% per year compounded monthly is the same as 1% per month compounded monthly. That's by the definition. That's because we took that 12% and we divided by 12. We got 0.01, and you can see that all the math ended up being the same. So these two things are equivalent. If we say we have a nominal interest rate per year and compounded monthly, well, you take that, you divide it by 12. In this case, it turns out to be 1% per month compounded monthly. Those two problems are exactly the same. So if we wanted to know how much does the account have after 1 year, well, 12.68% per year, we're going to have $112.68. So what's the effective interest rate per year? Well, we've already calculated that, 12.68%. And how much does the account have after 10 years? Well, because it has the same effective interest rate, we're going to get the same answer after 10 years, $330. All right, so we answered those questions. Now, sometimes it's compounded even more frequently than that. So here's an example. An account is said to have a nominal interest rate of 12% per year, but interest is compounded daily. Not monthly, but daily. It begins with $100 at the beginning of the year. What's the effective interest rate per year? Once we have the effective interest rate, we can answer all the same questions. We won't go through all that over again, okay? So that's 12% per year compounded monthly. This is now 12% per year compounded daily. All right. The effective interest rate now per year is 1 plus r over m to the m minus 1, but now r is equal to 12% still, but m is the number of times per year it's compounded, 365 days per year. So plugging everything in, we get 1 plus 0.12 divided by 365 now, all that gets multiplied by 365, subtract 1, and we get 12.74746. And you'll see in a second why I wrote down so many decimal places. So a little bit more than compounding monthly, not a lot more. It turns out even if you compound much more frequently, every day instead of every month, the effective interest rate that you get per year is not actually so much different. It only changed in the first decimal place or so, okay? So that's the effective interest rate per year, and from that we could use the same formulas. Once we have effective interest rate per year, we can use this formula to calculate how much we have after a certain period of time. So 12% interest compounded yearly is 12% effective interest per year. 12% interest compounded monthly we saw was like 12.68% effective interest per year. 12% nominal interest per year compounded daily was like 12.74% interest effectively over the course of the year. And you could take that process and you could, make it even more fine-grained, once per hour, once per minute, once per second, once every instant. And so that's what this chart is kind of showing, is the number of times compounded per period, the effect of that on the effective interest rate that you get. Of course, if you compound once per year, you start out, even if it's a nominal interest rate of 20%, if it's compounded once per year, it's 20%. And here is 12 months per year, and here is 365 days per year. By the way, this is on a logarithmic scale, and it asymptotically approaches some number. So what's that number? What's that number that it approaches? Well, you can show with a little bit of calculus that if you have a continuous compounding every instant, then what's the effective interest rate per year? It turns out to converge to I is E, the base of the natural logarithm. So the effective interest rate per period is I. The nominal interest rate per period, or APR, annual percentage rate, R. And E is the base of the natural logarithm, 2.718, etc. All that minus 1. Okay, so let's do that. Let's do this problem, and then we'll be done. So that was 12% per year compounded daily. And we noticed that compounded monthly, it was 12.68. It seems to be approaching some sort of asymptote, and it's going to turn out that you'll see that this formula that we have for 12% per year compounded continuously is going to be pretty similar. I is equal to E to the nominal interest rate minus 1. In this case, this is still that 12%. We can just calculate E to the 0.12 minus 1. Let me calculate that out. And that is going to give us 12.749685. All right, so we haven't changed very much. So it doesn't really matter whether you compound daily or hourly or every minute or continuously even. It's going to be it's going to converge towards this number. All right, so those are the sorts of problems you might see about interest rate on the FE exam. So basically when you get a problem and it says it is some nominal amount, some nominal interest rate compounded monthly, or compounded daily, or continuously, whatever, you use the right formula. So you just need to remember the formulas for the effective interest rate. You need to remember that the effective interest rate, is 1 plus the nominal interest rate, R, divided by the number of times per period it's being compounded, taken to the power of M, subtract 1 from that. You need to remember, if it's continuous compounding, then it turns out that the limit of this, as M approaches infinity, so not 365 times per year, not a million times per year, but infinitely many times per year, so every instant, it turns out that I is equal to E to the E to the nominal interest rate minus 1. And finally, once you have the effective interest rate, I, corresponding with your year, then you can get the future amount is equal to the present amount times 1 plus whatever that effective interest rate. Must use effective interest rate here to the number of years, or whatever your period is. So remember that you cannot just plug in the nominal interest rate. It's not the same as R. You need to calculate I first and plug that in.